Welcome back to week 6, and we are going to take a closer look at arid environments, and specifically what we're going to look at is how erosion and deposition occur and what the landforms are produced, and we'll briefly talk about some of the hazards that exist. So weathering and erosion in deserts, well, it's mostly going to be chemical and wind with a little bit of water. We'll kind of talk about that next, and we'll talk about deposition, and then we'll get into the major landforms. So, weathering in deserts, well, we've got wind and water, and we'll get into that in the next slide. And one of the main things that happens here is because there's very little water present, we don't have things like clays being created, we don't have dissolution happening, but what we do have is oxidizing conditions. And so what you can see here in this mountainside here is one thing is it's red, so you can see it's got a really nice bright color, and that's because there's oxygen present. And then what you also see is what's called desert varnish, and that's what this black color is on the rocks that you see here, and this is in Utah along the Green River, you can see in the foreground. And basically what happens is that manganese and iron that are in the environment, in the rocks, maybe blowing in the wind, are left on the rock surface. So you see this kind of crust that exists. And a lot of cave drawings and I guess it's petroglyphs is what they would be, the ones that are carved into the rock. I always say the wrong thing. But basically they're carved into this desert varnish, and you can really see them very well. So we've got that occurring on the surface, and we can also have a little bit of mechanical weathering happening. So because temperatures fluctuate pretty dramatically, going from maybe freezing at night in the winter time. This is pictures were taken in November, so during the day we're walking around in t-shirts, shorts, it was maybe 60-70 degrees, and then at night we would get pretty cold at night. It get down to maybe in the 30s, and one morning woke up and there was frost on the tent. So temperatures change pretty dramatically. So what happens to the minerals in these rocks is because the temperature is changing, the minerals, certain ones are expanding and contracting every day on a daily basis. And so what happens is that because you have that shrink swell, the rocks start to break apart, and you see this flaking off, kind of like peeling the layers of an onion away of the rocks. And so you see this nice round surface and these huge round boulders over here. So this is in Big Bend National Park, and this is Joshua Tree. So two desert environments, but very similar landforms being created. What also can happen is because we also have some water that falls occasionally in deserts, only in the springtime, very rarely. We see a lot of dry valleys. So these are called arroyos, and I always pronounce them wrong, so if someone would like to correct me in lab, I'd be welcome to that. So basically this river is dry most of the time, so we were there in November, and you can see it's pretty dry. There's some vegetation growing because this is a spot that periodically gets water, and the water table might be fairly close to the surface, so the roots can actually get back into that water table. These are going to be fairly steep in places, pretty narrow, and these empty into wide valleys and produce another landform we'll talk about next. And so these dry valleys, you can see they transport a variety of sediment. There's sand, there's larger boulders, and depending on how big the rainstorm is, you might get a slow trickle through here, or this whole valley might completely fill up with water. Here you can see just the evidence that yes, water does flow here. You can see evidence of a waterfall that might exist sometimes in this environment. So water plays a little bit of a role, but not a huge role. It's mostly wind that's going to be eroding, because throughout the year wind is always going to be blowing through here, daily cycles. At night when you have the land surface is starting to cool off, radiating the heat up into the atmosphere, you no longer have the sun heating the surface up, you get these winds that get produced, and that's going to carry sediment. It's going to basically sandblast some of these mountains and these valley walls, and when that happens, it's going to deposit that sediment, loose sediment in this valley, and then when a rainstorm comes through, the rainstorm's going to flush this sediment out. And when it flushes that sediment out, what we end up with, when that river valley empties out into a flat, wide valley, so here you can see is the mountain range with the rivers flowing out of. This is a wide, flat valley. Here's an aerial photograph, so river valley coming down through the mountains, and it empties into this wide, flat valley. That water's rushing down, a lot high volume, high discharge, and as it hits that wide, flat valley, it's going to immediately slow down. And as it slows down, it's going to drop the sediment it's carrying, and it spreads out and produces this fan shape that you can see, and that's why they're called alluvial fan. Fan shape, and then it's alluvial deposits that are left behind. And so this is Death Valley, the bad water fan. This is a kind of a side view of what one would look like inside this much larger valley that is produced. And these valleys that we end up seeing, here's another view of these. These are called playas, and here's the mountain ranges on either side. There might be a couple alluvial fans in here. Here's another one, same valley, mountains on either side, very flat on the inside of that valley. And these are called playas, where you have this wide, flat area where in the wet season it might fill up with water. We call that a playa lake. And then it might drain out or evaporate away during the dry season. And what you're left with are clay deposits, which is why it has that brown color, and salts, and that's why it has the white color. And that's what you see here is salt deposits in this area. It's just absolutely amazing topography. So the next question is, well, how do you get these mountain ranges and wide flat valleys? What creates that? Well, we call this topography horst and graben, or basin and range. And here you can see an aerial photograph or a side view of these ranges or horsts, the high parts you can see sticking up, and then the low parts, the range or the graben, in the middle. And then here you can see where that playa is, the bottom of the valley, and the mountains on either side, so the ranges or horsts on either side. So how does this form? Well, I got this great animation to show you, but basically what happens is you have a normal fault, and we'll talk about these faults next week when we start talking about earthquakes and geologic structures and whatnot. But basically you have a fault that occurs, one side moves down, one side moves up. And this picture is actually, the arrows should be reversed. So let me show you the animation. Okay, so let's play that animation over again. So you see we've got our flat surface, and then we've got this graben portion sliding downwards, the horse moving up. So we'll play that again for you. So we have tension pulling on the crust, pulling it apart, and then because of that tension it breaks, it produces these faults, and then parts of them are lower down and parts of them are raised up. So this would be where the playa would be, and these are the mountains around it. So you'd have the arroyos eroding away these horsts and depositing the alluvial fans in the grabens. So one more time there. There's your horse and graben. Fantastic. So the next landform that I want to show you that form in arid environments are mesas and buttes. So here I've got mesas, huge scale, absolutely enormous. Buttes, much, much smaller in size. And this happens because you have differential erosion of rock layers. So you have some rock units that are very, very resistant and hard to erode. So that would be this top layer. So it kind of provides a cap or a protective layer on top, whereas the layers below, you can see, has this gradual slope all around it. Those layers would be easier to break down and easier to erode. So they are producing this low slope, whereas the resistant layer produces a steeper slope. And here you can see a butte where we've got steep sides. These are our resistant layers, and then the gradual slopes would be the ones that erode much easier. So those are mesas and buttes. Sediment is also transported by wind, and just like in a river, we've got a bed load, so the particles that are moving along the surface of the earth, and we have a suspended load, the particles that are moving through the air. And basically when sediment is transported by wind, depending on how fast the wind's blowing, You might get finer particles, you might get coarser particles. It just depends on the speed. But usually you have pretty fine particles, sand-sized, clay, silt-sized particles that get transported from place to place and end up sandblasting the topography and any rock units that might be sticking up. And then they deposit in dunes. So some of the fine dust that gets blown from place to place, here you can see a dust storm in Sahara in Africa, blowing dust across the Atlantic, tons of dust in the air, and some of this dust actually reaches the Caribbean and can go up into the northeast. There's a great video I posted if you were interested in some of the health effects of this dust blowing across the ocean. It is damaging to coral reefs. It can bring microorganisms with it. So if you're interested, it's about a 10-minute video if you want to watch that. But we also get the deposition of the sand in the form of dunes. And depending on how much sand supply you have, if there's bushes present, you might have pretty small amounts of sand, so you have small dunes present. If you have a lot of sand, you're going to have big, wide expanses like you see here. And you have lots of different kinds. Your book goes into the various types of dunes. I'm not going to ask you to know the different types, but just know that there are different forms, different shapes that occur, and a lot of that has to do with the sand supply and also the topography, the wind direction. Is it steady in one direction or not? Is there vegetation present to help anchor some of the sand and ground it so it doesn't blow away? So how do dunes move? Well, they actually migrate from place to place, and this is one of the hazards that we're going to talk about next. But basically, when we look at a dune deposit, we see these lines in the dune deposit all over the place. And basically what that is it's showing you how that sand moved in the past. So what happens is you have a steady wind direction, you have a buildup of sand, so sand grains are going to bounce up one side of the dune and then slide and be deposited on the lee side or the slip face of the dune. So this is how you can tell the wind direction from deposits that are left behind, like this one. We've got an old deposit left behind. We see our slip face deposits here. They're kind of cut off on the top. That tells us the wind direction was moving towards the right. So here we can see the migration of a dune. If this process continues over and over again, we're going to erode particles from one side, deposit them on the other, and so we end up with this layering that develops in the dune. So because these dunes migrate, they can actually take over various environments. And it's one of these hazards, is migrating sand dunes. These sand dunes here in the Sand Sea in California move as much as 5 meters a year. So pretty significant movement. If there's anything built in this area, which I highly discourage that, you're going to be engulfed in dunes periodically. There's a Walmart on the coast that is built right next to some sand dunes in the Oregon coast, and they have to, every year or so, have to dig out their parking lot because their dunes are migrating into their parking lot. You can see that here. This is in Africa, and these dunes are actually starting to migrate into this city, the capital, that you can see here. So migrating sand dunes can be a problem, and there really isn't anything you can do to stop it. The wind's going to take it and move it. We can also have dust bowls or dust storms. So this is actually what happened in the U.S. and could happen in the future. What happened is in the 1930s, there was a major drought, and this whole area, they just started farming. They didn't have sufficient irrigation to be able to withstand that drought. So a lot of the crops died. The crops were holding the soil in place. When the crops die, they're there to keep that soil in place. Winds picked up and carried that loose soil from one place to another. And here you can see one of those dust storms, courtesy of Kansas State University. And this is Illinois University. You can see the cars and things that are just engulfed in the sand that was transported from place to place. So pretty scary stuff. And if we were to have a major drought in the Midwest and not have the water to irrigate a lot of that farmland, we could end up in a very similar situation. So if our climate changes enough to bring a major shift from somewhat wet conditions to more drier conditions, we could have some serious problems. We can also see major lake bodies. We see this a lot today, not only in this example in Africa, on Lake Chad, but this is happening in Georgia every summer. Because they don't get a lot of rainfall, we end up with very little recharge to the groundwater, and that's where all of the drinking water comes from for these towns and cities. And so in the summertime, they're still pumping that water out, and so we see drops in lake levels in those areas. And a lot of places like in Georgia and Florida in the summertime, when it's a really bad drought, they will send out warnings and they say, hey, you can't water your lawn, you can't wash your car, because we don't have the water. And this is actually a problem. You guys are going to look at one of these in lab this week, and a sea that's actually disappearing, and just like this one. So here you can see 1973, the size of Lake Chad. And in these top images, the blue is water, the red's vegetation. Bottom, the blue is water, the green's vegetation. So you can see we've got pretty big lake, 1973, 1987, significant decrease in size. 1997 still decreasing, and then in 2001 we've hit kind of a plateau here, and things haven't changed too much. You can see there's rivers flowing into this. Part of the problem here is in this area, this is right on the border of the Sahara Desert. Conditions are getting drier. There's lots of farmland in this area, so the rivers that are flowing into this lake are getting diverted for irrigation. Wells are put in to pump the groundwater out to irrigate. So we're decreasing the amount of groundwater present, and that's where this lake gets its water from, and from these rivers that flow into it. So we have much more use of the water, causing this decrease. So how can we, what's the silver lining to this cloud? How can we change this? Well, we can change the way that we irrigate. So we can use drip irrigation instead of spraying it across crops. It's expensive, however. Can use various ways to try to decrease the evaporation of that water by using plastic sheets. Maybe storing water underground, storing rainwater, so that in those in-between times when you don't get rainfall, you still have it. That way it's not evaporating away. Various things that we can do, change our habits so that we're not using quite as much water. I know that seems funny in this neck of the woods where we get lots and lots of rain, but there are places where it's getting to be a troubling story. So we'll see what's going to happen in the future if we all change our habits and start to try to protect our water sources. Then we'll be in good hands. So those are arid landforms, major types, major landforms, and some of the hazards. I will see you in lab.